what happens when there's a conflict in a routing table? So the router has to make a decision, well, which is the better one to use? Well, there is a way that it does that. As a matter of fact, RIP is not, you don't have to have just one routing protocol. It's possible for me to put 2, 3, 4 different routing protocols all on the same router. So it might learn about routes through one routing protocol and learn about the same route through another routing protocol. And so how does it decide which one to use when there's a conflict? Well, first of all, it's going to have a hierarchy of ways that routes are learned. And that hierarchy is called the administrative distance. You can see that number right here. In the case of RIP, there's an administrative distance of 120. So here's basically how it works. Directly connected routes are an administrative distance of 0. They are the most reliable. The lower the administrative distance, the more reliable it is. And so if it's directly connected, well, that's pretty reliable, because a directly connected route, the router can see it, and so it knows that it's very reliable. The second one are the static routes, and you can see here that it has an administrative distance of 1. So that's just a little bit less reliable than a directly connected route, which has an administrative distance of 0. Now, each routing protocol has its own administrative distance. You don't need to learn what they are for purposes of this series, but you can see that RIP has an administrative distance of 120. Now, behind that administrative distance, you also see another number, a 0, a 1, a 2, and so on. That is a metric. So within that administrative distance are these metrics. And in the case of RIP, that metric has to do with how many hops. 0 hops away, 1 hop away, this is 2 hops away, and it could be up to 15 hops away for RIP. With other routing protocols, it's not how many hops, but some other number that's based on things like how fast the lines are, how reliable the lines are, is there a lot of jitter, is there a lot of delay. Those can all figure into the administrative distance for different routing protocols. So we're going to look at the administrative distance first. Once we choose the administrative distance, then we will look at the metric and see, well, which is the best metric. If I can get there in 1 hop, or I can get to the same network in 2 hops, well, I would choose the 1 hop in the case of RIP. So that explains what these numbers are over here. These are administrative distance and metric. And you'll just want to remember that directly connected is most reliable. Static route is second most reliable. And then whatever the metric is for, or I should say administrative distance is, for each individual routing protocol is next, as well as the metric. Now, there is one other thing that isn't obvious here. The most specific route wins. So if I have a general route, and then I've subnetted that down to more specific routes, and here you can see I've got some subnetted routes. The subnets are more specific. Those are a smaller range of IP addresses, and so they would win over the more general ones.